The next concept we're going to learn in our simplifying unit is exponent rules. So we saw a little bit of an introduction to that with some very basic exponent rules, and now we're going to take a look at how to simplify some more complicated expressions with powers in them. So first of all, it's really important that we understand what the word coefficient is. A coefficient is a number that is multiplied by a variable. The reason it's so important to be able to differentiate between a coefficient and an exponent is because we treat them differently when we're simplifying expressions. And I get a lot of students, once they start seeing coefficients and exponents in the same expression, they start treating them the same, and they are not. A coefficient is not an exponent, so it does not follow the exponent rules. It's really important to understand this, and I'll continue stressing that concept throughout this lesson. Next, we have what is a power, and a power is the entire expression or term that contains an exponent somewhere. So as you can see in our example, we have a power with a coefficient of 8. Notice how 8 is being multiplied by the variable. The base of the power is x, and the exponent is 2. The properties of exponents that we're going to focus on in this lesson are listed on the page here. We're going to take a look at our multiplying rule. So if you have a power times a power, you add those exponents. And as a reminder of why this works, we've got an example. If we have x squared times x cubed, and we write these out the long way, x squared is x times x cubed is x times x times x. And once you write it out the long way, you can see why we're adding those exponents, because we're really multiplying 5 x's together. Our second rule is our dividing rule, and we'll subtract the exponents. The reason this works is if we had x cubed divided by x squared, and we wrote these out the long way, in our numerator we'd have x times x times x. In our denominator, we have x times x. And what happens in this case is a pair of x's cancel, because x divided by x is 1. Notice they're canceling to 1, not 0. That's really important on the next rule we're going to talk about. And it's x to the first power, or just x. All right, and rule 3, why does this work? If we look at it as a power over itself. So if we have x squared divided by x squared, expanding each of these, we have x times x divided by x times x. And again, they cancel by division to 1. Anything divided by itself is 1. Thinking about this using that dividing rule we just talked about, if we subtract the exponents, we get 0. So this is why x to the 0 power equals 1. It's really important to understand why these rules work, and then you will be able to apply them correctly. If this process doesn't make sense to you, the why the rules work, then it's going to be much harder to get our expressions simplified. Our essential question for this lesson is, how do the power rules work? So that's what I just explained in the last slide, and it's important, again, I can't stress this enough, to keep that in mind as you're simplifying these expressions. Also note in the right-hand column, I have a warning for you. Treat coefficients like normal, regular numbers, like you've been treating numbers your whole math career. The exponents have different rules, so make sure you apply the different rules to the powers than you do to those coefficients. So let's start with our first example. And I'm going to start by treating my coefficients like regular numbers, and this is telling me to multiply my numbers together. So the coefficient of 3 times the coefficient of 6 gives me 18. And now I'm going to treat my powers like powers. I'm using different rules with my exponents because they work differently than coefficients. So I've got x squared, or x times x to the 5th, or 5 more x's, for a total of 7 x's that I'm multiplying together. Notice I multiplied my coefficients and I added my exponents. I treated them differently. Next one, same thing. We've just got an extra variable thrown in there. So again, I'm going to start with my coefficients, and I am going to multiply my coefficients together. -7 times 5 is -35. And now I'm going to treat my exponents like exponents, and they have different rules. So w to the 4th times w to the 9th, I'm really multiplying 13 w's together if I think about expanding those and writing them all out. And finally, I've got z cubed times z cubed. If I were to write all of those out, I would have 6 z's being multiplied together, or I'm adding those exponents.